Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Washing Machine Spin Cycle by Will Power. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have arrows, where numbers on arrows sum to the number in the arrow's circle. So, for example, if this were, say, 3 and 5, this would have to be 8, because these two digits along the arrow must sum up to the digit which is in the arrow's circle, which it does. 3, 5 add up to 8. We also have crop key pairs, where numbers with a white dot between them are consecutive, and numbers with a black dot between them are in a 1 to 2 or in a ratio of 2 to 1. Not all possible dots are shown. So, for example, if this were, say, a 6 here, this would have to be 5 or 7 to make sure that these digits are consecutive. And if we had a 2 here, this would have to be 1 or 4 to maintain the 2 to 1 ratio that's between them, because there's a black dot between them. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. So one thing you know about arrows is 9 can never be on an arrow if it's adding up with another digit to add up to a single digit, right? It just makes sense, right? Any digit that's not in normal Sudoku, which means we don't have a 0, so it's 1 or greater, plus 9 is not going to be a digit, right? 1 plus 9 is 10, which is not a digit. So we know 9 cannot be on these arrows here. 9 cannot be on these arrows here. 9 then has to be one of these 3 digits, one of these 3 digits, one of these 3 digits, and one of these 3 digits. Well, in the central box then, 9 cannot be here because of the 9 here. 9 can't be here because of one of these is 9. 9 can't be here because one of these is 9, and 9 can't be here because one of these is 9. Therefore, this is a 9 here. Okay. Anytime these digits are consecutive, this digit must be smaller than this. Anything on the arrows must be smaller than the digit in its core. Must be less than or equal to, I should say, any digit that's in its circle, right? And that just naturally follows because any digit on the arrow must either be the same as a digit in the circle or add with another digit to add up to the digit in the circle. Well, since these are consecutive, they have a difference of 1, and this must be bigger, so therefore this must be 1 here. So 1 plus something is another digit there. Therefore, we have 2 digits which are in a 1 to 2 ratio, or 2 sets of digits, I should say, which are in a 1 to 2 ratio, which add up to a single digit. Since we don't have 1 anymore available, that means the only possible combinations are 2 and 4 adding up to 6, and 3 and 6 adding up to 9. So this must be a pair of 2, 4, or 3 and 6, which means this is 6 or 9 here. If you have, so if this is 2 and 4, that would force this to be 6. And then this would not work as a 1 to 2 ratio, right? The only remaining digits we would have available, which could be next to a black Kropke dot. So 5, 7, and 9 can never be next to a black Kropke dot. And the reason why is if you have 5, 7, and 9, you get 2.5, 3.5, and 4.5, which are not digits, obviously. If you double 5, 7, and 9, you get 10, 14, and 18, which are not digits. So the digits that can be next to a black Kropke dot are 1, 2, 3, 4, 6, and 8. Well, if this is 6 and this is 2, 4, sorry, if this is 2, 4, which adds up to 6, that would force these digits remaining to be 1, 3, and 8, none of which are in a 1 to 2 ratio with each other. Therefore, this cannot be 2, 4, and 6. It's 3, 6 adding up to 9, which makes this 6 and 2 and 4 to be in a 1 to 2 ratio. That means this has to be either 1, 2, 4, or 8 left. Okay, this digit must add up to this one with 1. You cannot have 2, 3, 4, 6. So if you have a 5 here, that would be 6, which is not possible because we have a 6 in the box. Or 6 in the row. So this can't be 5. If it's 1 and 7, that would be 8. If it's 1 and 8, that would be 9, which is not possible. So this must be 1, 7, adding up to 8. Therefore, the remaining digits in this right central box are specifically 5, 8, 9. 9 can't be here because of 9 in the column. This can't be 8 because of 8 in the column. Right. So what else does that tell us? Not too much. These digits cannot contain 6, 8, or 9. So it could be 1, 2 adding up to 3. That's possible. 1, 3 adding up to 4. 1, 4, or 2, 3 adding up to 5. 2, 5, or 3, 4 adding up to 7. And those are all the possibilities. Okay. These digits cannot have 2, 4, and 6 in them. To be consecutive, you have to have an odd digit next to an even digit, right? If these are consecutive. Well, we don't have 2, 4, or 6 available as an even digit. The last remaining even digit then has to be 8. And that's then one of these consecutive digits. So this is 8 with 7 or 9. That 8 eliminates 8 in the rest of the column and box, so this cannot be 8 here. So this must be 2, which is in a 1 to 2 ratio with 1 or 4. Okay. 3, 4, 5, or 7 is consecutive with this digit. If this is 3, that would force this to be 4, but 3 would have to have 1, 2 here, 4 would have to have 1, 3 here, and we'd have a duplicate 1 in this box. So this cannot be 3. If this is 4, we have the same problem, right? 4 would have to be 3 there, or 5. But if this is 4, this is 1, 3. If we have 3 here, 1, 2 would be here, and therefore we'd have a duplicate in the box. So it can't be 1, 3, 1, 2 here, and 1, 3 here. So this can't be 3. If we tried to have a 5 here, that also doesn't work. 1 and 3 would eliminate 1, 4 as a possibility to add up to 5. And 2, 3 as a possibility to add up to 5. So that doesn't work there. So this cannot be 4, because this can't be 4 and 5 there. 5 has the same problem with 4 being there, but you could have 6 or 8 here. And that does, I think, work. It would have to be 2 and 3. Because if it's 1 and 4, that would eliminate all possibilities for 6 here, right? Because that would eliminate 1, 5, and 2, 4 as possibilities if you have 1, 4 here. So it's 2 and 3, which forces this to be 1, 5 there. Or if it's 7, this would be 8 or 6. It cannot be 1, 6 here, so it would have to be 2, 5, or 3, 4. And so if this is 6 here, this is 7. 2, 5, and 3, 4 eliminate 2 and 4 as possibilities. So this would be 1, 5, which would make this 3 and 4 here. Oh, that's another thing. So all of these arrows in these boxes are guaranteed to add up to at least 21. And the reason why we know that is what are the 6 lowest digits possible in a box? It's 1 through 6, and these are guaranteed to be unique, so they must be at least 1 through 6 here. So these 3 digits must add up to what these 6 must add up to, right? Because this is the sum of that, this is the sum of that, this is the sum of that, and it's the same for each of these boxes which have arrows in them. So this added up to 23. So this is 23, which made this 22. This must add up. So we have something similar here. This must add up to at least 21 here. So if we have 5 and 6 here, that would mean this is 9 at most there, which only adds up to 20, which this does not add up to. So this cannot be 5. This has to be 7 here. And you could have 7, 6, and 9. You could have 7, 6, and 8 also as possibilities. Or this is 7, 6, and 9. Or it's 7, 8, and 9. We don't know. So this could be 2 and 5, or 3 and 4. This could be many things. So we have something similar here, right? This has to be adding up to 21. So it's 4 through 9 here as possibilities. Or you could have 6, 7, 8. This also has guaranteed 8 here. So it could be 7 or 9 there. It could be something else entirely different. You don't have 4 available, you don't have 6. So therefore, if this is 5, this would force this to be 9. And then this would be 5, 7, 8, but that would only add up to 20. While this arrows would have to add up to 21 at least. So this cannot be 5 here, which means this must be 7, 8, 9 as a triplet here, which eliminates 7, 8, 9 in the rest of the column. This can't be 9, it's 5, which makes this 8, which makes that 9. Remaining digits in column 7 then are 1 and 3. These arrows here must add up to 24. So these 3 digits must add up to 21 with a 9. So it's either 4, 8, 9, or it's 5, 7, 9 here. Okay. Hmm. 7 cannot be here and cannot be here. 7 cannot be next to a black Kropke dot, as we said before. So where is 7 in this left central box? It must be here. So 7 plus 1 or 7 plus 2 is 8 or 9. Okay. These are in a 1 to 2 ratio with each other. And this is 1 and 2. So you cannot have 1 and 2 as the 1 to 2 ratio here. Because of that, again, you have to have 2, 4, and 3, 6 as the only ones that work. So then this can't be 2, it's 1 and 7 also. So this becomes 2, 4, and 3, 6 again. That adds up to 6 and 9. 1 and 7 adds up to 8. Therefore, this can't be 8 or 9. It's 7, which is consecutive with 8, which makes that 9. So this cannot be 7, 8, or 9. Cannot be 7, 8, or 9. It's 4 or 5 here. And there's no more 4 or 5 here. This can't be 8. This can't be 9. Where's the 9 in this region here? It must be here. So that's 9. This then, again, must be 5, 8, and 9, adding up. 8 cannot be here. This is 5, 9 as a pair. We can't have 5, 8, 9 here. This 1 eliminates 1 here, so that's 7, which makes this 1. This has to be 5 and 8 here as a pair. because we don't have it available in row 5 anywhere else. We don't know what this is. This has to have an 8 here. And we have a 6, 7, 8, 9 quadruplet in column 3, which eliminates 6, 7, 8, 9 in the rest of the column. This can't be 8 or 9. It's 5, which makes this 9, which makes that 8. This can no longer be 6, so it can't be 3 and 6 in a 1 to 2 ratio. So it's 2 and 4 in a 1 to 2 ratio, which forces this to be 6 here. So this can't be 6. This is 8. That's 9, which means this can't be 9 there. This is 9 here. This adds up to 21 again, because these arrows add up to 24, which is what 7, 8, 9 add up to. This is 1, 3 as a pair. 6 eliminates 6 here, so this is 9, which means this can't be 2 or 4. It's 3 and 6. This has to be 4 and 5 with 7 or 8. So 4 and 5 is here. This is 7 or 8 here. We are guaranteed one of these digits is 4 and 5 because it's either 2, 5 or 3, 4 adding up to 7. And this is 4, 5 there. Therefore, whereas 1 in row 3 cannot be here, cannot be any of these, so it must be here. So this is 1, and this has to be 2 or 3 to correspond with these digits here. Okay. This cannot contain 4 or 5. So there cannot be 3, 5 here. So it's either 1, 7 or 2, 6 here. We have 2 sets of consecutive digits here. This can't be 1. So we know 1 has to be one of these digits there. Okay, remaining digits in row 4 are 1, 2, 3, 4, 6. 6 can't be consecutive, so this can't be 6 there. Remaining digits in row 6 are 2, 3, 4, 6, and 7. Interesting. Okay, we know this is either 4, 8, or 5, 7, adding up to 21 for these 3 digits. And that's 5 or 8 there, which eliminates 5 and 8 in the rest of the column. So this cannot be 5, which means it can't be 2. There can't be an 8 here. We could have 1, 8, no 4, 5 here. So 1, 8, 2, 7, or 3, 6. And again, this can't be 8, so this can't be 1. Remaining digits in this upper right-hand box. We have 2, 4, 5, 7. 2 cannot be either of these because of 2 being in the column here. 7 cannot be any of these because of 7 in the column here. So we know 7 has to be one of these. The remaining digits in row 7 are 1 through 5. And again, 1 cannot be adding up to 7. So this is 2 or 5 with 3 or 4 as possibilities. 1 can't be here, whereas 1 in row 7, it must be here, which means this cannot be 1, it's 2, 4 as a pair. That eliminates 2 and 4 in the rest of the column. And box, 5, 7 eliminates 5 here, so it's 2 and 4. This is either 2 and 5 or 3 and 4, which eliminates 4 and 5 in the rest of the row, because this is 4 or 5. So this can't be 5, it's 3, which means this can't be 3 or 4. This is 2 and 5, which eliminates 2 and 5 in the rest of the row. So this can't be 5, it's 4. 4, 9, and 8 add up to 21, because these add up to 24. 24 plus 21 is 45. 8 eliminates 8 here, so it's 5 and 8, which eliminates 8 here. So that's 7 and 5, adding up to 21. Therefore, this can't be 7 here. No 4, no 4, no 4 here. This cannot be 2 and 7. We have to have an 8 somewhere in these arrows, so it must be 1 and 8 here, which eliminates 1 and 8 in the rest of the row. This can't be 1. It's 3, which makes this 1. That eliminates 1 and 7 as a possibility here, so this is 2 and 6, which eliminates 2 and 5 in the rest of this row, or the rest of this box, so this is 3 and 4 here. which eliminates 3 here, so that's 2. No 3 here, no 3 here. We have 8 eliminating 8 here, so this is 1 and 8. 1 eliminates 1 here, so that's 2. 2 is only consecutive with 1 or 3. 2 eliminates 2 here, so it's 6, which makes this 2. 6 eliminates 2 and 6 eliminates 2 and 6 here, so that's 7. So this cannot be 7 here. Therefore, this can't be 6 to be consecutive with the 7, or to be consecutive with each other. And 2 can't be here, so this is 3, 4 as a pair, which eliminates 3, 4 in the rest of the row. This can't be 2, 3, it can't be 4, it's 2, which makes this 4. 3 or 4 eliminate 3 here, so it's 6 and 3. 3 eliminates 3 here, so it's 6 and 3. 4 eliminates 4 here, so it's 2 and 4. 3, 4 as a pair eliminates 3 here, so it's 1, which makes this a 6. Okay, 2 eliminates 2 here, so it's 4 and 2. 7 eliminates 7 here, so it's 5 and 7. This adds up to 8. There's no 2, 6 or 3, 5 available, so it's 1 and 7. And this can't be 1 because of 1 in the column, so it's a 7 and 1. 2 eliminates 2 here, so it's 5 and 2. 4 eliminates 4 here, so it's 3 and 4. That leaves this digit as a 6 and this digit as a 3. 3 eliminates 3 here, so it's 1 and 3. Remaining digits of row 1, we have 4 and 6. 6 can't be here because of 6 in the column, so it's 4 and 6. We have 3, 5 remaining in row 2. This can't be 3 because of 3 in the column, so it's 5 and 3. Column 1 has 4 and 5. This can't, so this is 4, 5 as a pair. Column 2 has 2 and 7 remaining. This can't be 7 because of 7 in the row. So that's 2, that's 7, which eliminates 2 here, so it's 4 and 2. 4 eliminates 4 here, so it's 5 and 4, which leaves us a 6 and a 5 in the rest of the grid. Yeah, I probably should have started with this, I guess. But this was fairly easy to follow here. And then I realized that, yeah, the arrows had to sum up to 3 unique digits. So it had to be at least 21 here, which restricted these digits a lot. Anyways, I hope that makes sense about how I was attacking this. This is definitely very easy if you sort of understand how to sort of attack it. Obviously, if you don't, it can be pretty difficult to start tackling, but maybe you can sort of stumble onto it too. I don't know. Either way, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.